Good day to everyone and welcome to Boosters for Valve Systems. Today we will be going through the purpose, operation, and how a volume booster improves system performance. First, the purpose of a volume booster in a valve positioner system is to achieve a higher flow than could normally be achieved with a positioner alone. Most positioners have very little flow, and to increase the speed at which a valve can reach a desired position, a volume booster is employed. Here you can see a cutaway of a model 4500 volume booster with and without the bypass valve. As you can see, with the bypass option, a passage is made from the signal chamber to the outlet port of the booster. The bypass adjustment is made by turning the adjustment screw to shrink or expand the proportional deadband and deadband zone. It does this functionally, but actually the differential pressure characteristic is modified by the adjustment of the bypass valve. With a valve system, the booster will receive a pneumatic input from the positioner, and this forces the signal and control diaphragm down and opens the supply valve to let air pass to the outlet port. Essentially, it is the same when reducing the set point. The booster receives a lower signal, and this time the diaphragm assembly moves upward, unseating the exhaust valve, relieving the pressure to the desired set point. Next, we will move into what Fairchild has to offer in the realm of volume boosters for valve package systems. We offer a wide range for many application needs. To begin, we have the Model 20i, which is a CV of 1 and flows up to 45 SCFM. The Model 20 comes in port sizes of 1/4, 3/8, or 1/2 inch. The Model 20, along with all of Fairchild's volume boosters, has a maximum supply pressure of 250 psig and a maximum output pressure of 150 psig. Moving right along, we have the Model 4500 AI. This volume booster has a CV of 3 in both directions when a tapped exhaust is selected. This unit will flow up to 150 SCFM and has port sizes of 3/8, 1/2 inch, or 3/4 inch. Again, 250 psi max supply and 150 max output. Next in line is the Model 4800A. With this volume booster, there is no need to specify the I option. The Model 4800A has a CV of 9 in both directions and flows up to 500 SCFM. The port sizes available with this unit are 3/4 and 1 inch. Lastly in the line of volume boosters for valve package systems is the Model 200 XLR. This unit flows up to 1800 SCFM and has a CV of 18 in both directions. The only available port size in this unit is 1.5 inch. The I option for the Model 200 XLR is a special Z designated part number. Next, we will be moving into the demonstration portion of the video. We have here a Siemens PS2 positioner and a diaphragm type valve that we will be working with. The positioner will give an output pressure range of 0 to 25 psi with an input of 4 to 20 milliamps. The positioner is supplied with 30 psi of shop air. First, we will perform an open to close and close to open operation with just the positioner and valve alone. As you can see, we have 4 milliamps, which is 25 psi input, to the valve, and you can note the position. We will then supply the positioner with 20 milliamps and thus 0 psi input. You can see moving from open to close or close to open with the positioner alone will take quite a lot of time. Approximate time for the positioner alone is around 7 to 8 seconds. The next demonstration will be with the same positioner and valve, but a standard Model 20 will be added. Let's see what happens. Again, we have 4 milliamps at 25 psi and 20 milliamps input gives 0 psi. The valve moves from open to close, but this time it is much faster. It only takes approximately 2 to 3 seconds instead of the 7 to 8 seconds with the positioner alone. Let me show you why you can achieve a desired valve position faster with a booster. Here's a graph that depicts the speed of an actuator with a volume booster. Actuator speed is on the vertical axis and valve position is depicted on the horizontal axis. As the set point moves away from the current valve position, it will initiate a speed response depending on how far away the new set point is away from the current valve position. The new set point shown on the graph crosses the actuator speed line at about 2/3 of the maximum speed of the system. The maximum speed is a function of the flow capacity of the volume booster and the size of the actuator. As shown in the graph, the speed capacity of the valve positioner is small compared to the speed capability of the volume booster. Faster speeds can be achieved by using a higher flow capacity volume booster or multiple volume boosters. We do, however, encounter a problem with the standard Model 20 when placed in a valve positioning system. The problem is not speed, but overshoot. As seen here, we will go incrementally instead of fully open and closed. As shown here, the valve has begun to oscillate. This is due to overshoot. The overshoot is a product of the responsiveness of the positioner and the volume booster. To overcome this oscillation, the responsiveness of one of these will need to be dampened. This moves us into our next and final demonstration with the positioner, valve, and Model 20 with the eye bypass option. Again, you will see 4 milliamps producing 25 psi and 20 milliamps producing 0 psi. Again, moving from full open to full closed, or the opposite, the time is 2 to 3 seconds. Going incrementally 8, 12, and 16 milliamps, we'll see no oscillation of the valve. This is due to the bypass valve. Here's a picture depicting the valve stem position in the volume booster. When a new set point is chosen by the operator, the positioner will send a signal to the booster. The booster then reacts to achieve the new set point. The supply valve will move to its full open position. At this point, the valve is moving rapidly toward its new set point. When the set point is near, the valve begins to slow as it enters the proportional deadband of the booster. The booster supply exhaust valve will fully close once the deadband zone is reached. With both the supply and exhaust valves closed, the positioner takes over and makes the final adjustment through the bypass of the booster. The speed of the valve is slow within this zone because the flow capacity of the positioner is small. In conclusion, the volume booster with the eye option will produce a faster responding valve package system while eliminating hunting and oscillation of the valve. As you have seen, Fairchild has many sizes of volume boosters to accommodate various applications. If you require a quality, rugged, and precision volume booster for a valve positioner system, let Fairchild fill that need. You have world-class customer service and technical support at the ready to serve you and your customers. We at Rotork Fairchild would like to thank you for watching today, and please don't hesitate to call for assistance with all your pneumatic needs.